In this video, we're going to look at derivatives and integrals of vector functions. So, first off, a quick review. Vectors, we can write them in two different ways. So the vector u, and I'm going to use bold-faced notation for vectors. I could write this as an ordered pair. So that would be with the components u1 and u2. Or I could write it as the sum of the unit vectors. So that could be u1 I being a unit vector, plus u2 j. And as a reminder, this notation just means that we sort of have the vector that would go from the origin to the point u1, u2. The I vector is just the vector that points one unit right and no units up. The j vector is the vector that points no units left or right and one unit up. And the derivatives and integrals are actually very easy. So let me define the vector valued function u of t to equal either the function f of t, g of t as the ordered pair, or f of t I, sorry, that's a j, I plus g of t j as the sum of the unit vectors. And I don't care which notation. I actually usually prefer this notation over here, but I would say mimic the notation that's given to you in the problem. So if they give you the unit vector, use the unit vectors. If they give you the ordered pair, use the ordered pairs. So the derivative with respect to t of u of t will be just the derivative of the components, f prime of t, g prime of t, which I could also write as f prime of t I plus g prime of t j. And a quick rationale for that. So since this is the sum of two orthogonal vectors, that I can follow the sum rule for derivatives. And I can take the derivative of this plus the derivative of that. I is a constant, j is a constant, so I just take the derivative of the varying functions, and we get this. Similarly, if I'm doing the integral, so the integral of the vector valued function u of t dt, that's the same thing as the integral of f of t dt, and the integral of g of t dt, which I could write as the integral of f of t dt I plus the integral of g of t dt j. Now, one last point before some examples. If I do this with an indefinite integral, I'm going to need to have two constants, c1 and c2. If I do it in this method, I can collapse both those into one arbitrary constant vector. That constant vector will be the vector c1, c2. So let's see three examples. Here's our first example. Given v of t, the vector you see, it's a little bit bold-faced, sine squared t, cosine t squared, evaluate the derivative. And so I can do this straight away. The derivative of this, I do chain rule, so I bring the 2 out to the front first, and I have sine to the first t. Then I have to do the derivative of the inner function. The derivative of sine is cosine. This one I have to do chain rule as well. The outer function is cosine, so the derivative of that is negative sine of t squared times 2t. And I generally like to bring coefficients or variables to the front of sines and cosines, so I would write that as 2 sine of t cosine of t and negative 2t sine of t squared. I could also write this as the sum of the unit vectors, so I could write this as, let me change colors for that, as 2 sine of t cosine of ti minus 2t sine of t squared j. And I guess it's also worth noting that 2 sine t cosine t is also a trig identity for sine of 2t, but this is fine. Okay, now this one, evaluate the integral of u of t if u of t is this. So I can do that as the integral of each part. So the integral of 1 over t is the natural log of the absolute value of t. I have a plus the constant there. The antiderivative of the integral of secant squared t is tangent t. I have plus the other arbitrary constant. And this is one acceptable solution. Or, and this is one I prefer because I was given the ordered pair form of this, the rectangular form. Or I can write this as the natural log of the absolute value of t I plus the tangent of t j plus the vector c, which includes c1 and c2 parts. So both are acceptable. One last example. Given the vector function this, evaluate the integral from 0 to pi of a of t dt. And I prefer treating this as the ordered pair. It just is sort of less writing, easier for me. So I'm going to do it this way first. I'll show it with the sum of the unit vectors in a second. And by a second I mean probably about a minute. So I'm going to do the integral from 0 to pi of 2t minus 1 sine of t. The integral of 2t minus 1 is t squared minus t plus a constant. The integral of sine of t is negative cosine of t. And I evaluate that from 0 to pi. So I put in the pi, and I will get pi squared minus pi. I put in the pi here. Cosine of pi is negative 1. A negative 1 is positive 1. And then I substitute in the 0. 0 squared minus 0 is 0. Cosine of 0 is 1. With this negative sign, gives me a negative 1. And pi squared minus 0 is pi squared minus pi. 1 minus negative 1 is 2. So that's one way to solve this. The other option, which is probably the better option for this problem because we're given the sum of the unit vectors anyway, is to go through and do the integral of this, which will be, the antiderivative of that is still t squared minus ti plus, antiderivative of sine is negative cosine, so I have minus cosine of t j, and I can evaluate this from 0 to pi, and it does the same thing. So I'll end up with pi squared minus pi I minus, put in pi here, cosine of pi is negative 1, negative 1 is plus j, minus, putting in 0, 0 squared minus 0 is 0, so I have 0i. I'll put this in here, but you don't need to write it. And I have cosine of 0 is 1, negative 1 j. And I can see that combining like terms, pi squared minus pi I minus 0i is pi squared minus pi I. J minus negative j is 2j. and we get the same solution. I hope this helps out. Feel free to comment below if you have any questions.